Example 6.1. Consider experiment 6.2. What would you do to obtain large deflection of the galvanometer? 6.2's experimental setup is given in your textbook. This is nothing but double coil experiment. Now what's the question? You have to get maximum deflection in the galvanometer. What is to be done? Maximum deflection in the galvanometer is same as maximum current because galvanometer is used to detect the presence of current, right? Now, according to Faraday's law, E proportional to d phi by dt. Induced EMF is proportional to d phi by dt. Now, E equal to IR, so I is also proportional to d phi by dt. I have to get maximum current means d phi value should be more, dt value should be less. D phi is more. What is phi? Phi is equal to BA cos theta. B dot A, BA cos theta. I have to increase the flux means I have to increase magnetic field as well as I have to increase area. Anyway, theta is 0 here, cos 0 is already maximum. So I have to increase B and A. How to increase B? I can increase magnetic field by increasing number of turns. So increase the number of turns. So B increases. Then second point, area. Area of the coil. Use a coil with a larger area. So I can increase B, I can increase A. 2 points correct, clear? Then what about dt? dt is to be reduced. dt is to be reduced means we have to bring the coil very quickly to C1. That is, move the magnet or coil. In this case, coil. Instead of coil, you can use the magnet also. You have to bring very quickly by moving the coil C2 or magnet very quickly to C1. So 3 points over. Then, is there any other way to increase magnetic field? One is by increasing the number of turns. Other way, using a soft iron core along the axis. Insert a soft iron core that also increases the magnetic field. Or use a strong magnet. Now I repeat, B can be increased by 3 methods. What are those? Number 1, increasing number of turns. Number 2, using a strong magnet. Number 3, using a soft iron core. 3 methods. So we can increase B. Area, we have to increase the area. Okay, then dt, we have to reduce. So current will be increased. We'll go for the second part of the question now. How do you show induced current without a galvanometer? Here galvanometer is given. Why? To detect the presence of induced current. Without galvanometer, we should able to show the induced current. How is it possible? For that, we can use a bulb or LED. It will glow. When a current is there, it will glow. So, we have to use a bulb or LED. Second one, spark method. These two coils, right? We have to bring very close. Then a spark will be produced. Bring coil terminals close to each other, then there will be a spark. Or you can keep one magnetic needle compass. Whenever there is a flow of current, magnetic needle shows the deflection. So out of 3, any method you can follow to get to show the induced current. First one, we are using bulb or LED. Second one, spark method. Third one, we are keeping a magnetic needle.